Thank you very much. So, hi everyone, my name is Denis. And today, in this particular session, I'm going to be talking about how to automate builds in .NET. And I'm going to focus specifically on the .NET side of things, but hopefully the ideas can be utilized either in other languages or in frameworks. So, without further ado, let's get to the plan. And I know there's that S before, but I forgot to fix it, so just ignore it. So here's the plan. I'll try to introduce you to build automation as a general concept. So we'll look at some steps that are actually a part of a build. And we will probably get an idea of why build automation is even worth having a speech about. We'll glance over some existing build automation solution and see how they separate from one another. When we have an idea of what is already out there, what exists, then we're gonna take a step back and try to get some or figure out some of the characteristics of a quote-unquote perfect build automation tool. And then, well, then we're gonna try to build one. So if everything works out, at the end, we are going to have a couple of minutes for questions and discussion. And if everyone's ready, let's just get to it. Okay, so we are here to talk about build automation. So just so we are all on the same page, I'm going to spend a couple of minutes talking about what a build in that sense actually is. So what I'm referring to when talking about a build is a process that transforms your code into an artifact that is ready to be deployed and executed, say, somewhere in the cloud. And the core step of a build process in .NET is usually the compile step. This is the part that actually turns your code into an intermittent language that the common language runtime can understand. I know this is very specific to .NET, but just bear with me. Before that step, however, at least in .NET, we usually do some restoration of packages. I know JavaScript has a similar concept. In that particular case, I'm talking about Nuget package restoration. Now, if we want to make our builds repeatable, it makes sense that before we actually start with restore and compile, we do a clean of our environment. So this just makes sure that our builds are repeatable, they're stable, and that there are no files where there shouldn't be any, basically. Now, anytime during executing these three tasks, we can actually start to run, perhaps even in parallel, some static analysis jobs that actually provide some metrics about how the code that is being committed or in a pull request, what standards does it reach. And at this point, we could probably just fail the build if the code is not up to our standards. Okay, after we are done with that, we need to test our code. Of course, everyone tests our code here, right? So usually we don't only run one type of tests, but there are many types of tests to run, just to name a few: unit tests, integration tests, and end-to-end tests. And all of these tests usually require, at least to some degree, specialized environments. So you need to have data ready and so on. Okay, so now that we run our tests, it makes sense that we actually calculate some code coverage. And this is another metric that is very cool, a cool way to determine that the code that we are committing or merging with a pull request is actually up to standards. Here we can also decide to just fail the build because you're missing a test. But after the code is tested, after it's compiled, after we know that the product works the way it should work, it's time for packaging. Now, this is the step that actually produces the main artifact of this entire build workflow. And a package can be either an application, it could be a zip file, it could even be a Docker image. It doesn't matter. What matters is that this is the product of our entire build. And when we're done with packaging, we can deploy it. I'm not gonna spend too much time on deployment because this is probably worth another speech on its own. So I'm just gonna continue to the next step, and let's take it from the top. So, build automation is a process that aims to automate and connect all of the steps that are related to a build workflow. Of course, we're not usually limited to just these core build steps that I've shown in the previous slide. Versioning, assembly weaving, signing code, everything and even more could be a part of a build workflow. So imagine any tedious task that a developer can do either during deployment or development. Well, that's a great candidate for actually automating it. Okay, what about tools? I'm sure there must be some tools out there. So generally, build automation has been a part of the DevOps arsenal since its very inception, right? And generally, we can divide build automation tools into two distinct categories. First category are build automation servers. Now, these are usually synonymous with continuous integration servers, just so we don't think that there's another concept out there. And they provide a means of executing automated tasks, in our case, builds, and they are executed on a scheduled or a triggered basis. Say a new PR is created, or it's been 24 hours since the last release. And this build workflow is usually defined in a specific notation. This is usually in YAML, JSON, XML, or even some user interface. So build pipelines that are set up on build automation servers usually require specialized and vendor-specific software to actually execute. And the build notation, the build pipeline notation I was talking about is usually very specific to the server of choice. Now, that becomes an issue when, say, you're trying to migrate away from a specific build automation server, or, for example, if you're trying to run exactly the same build locally. So, another category of build automation tools attempts to solve this issue, and those are build automation utilities. Now, these are usually tools meant to be used by the developer, but they do offer some integration with continuous integration servers. And the issue that these tools have is that they're usually written either in a different, say, a scripting language, or a DSL that is very specific to the concept that the tool is trying to solve. And also, when running on CI servers, these tools tend to not utilize the resources of a CI server to the fullest extent. So it appears that there's some lack or some divergence between what existing tools offer and what the developers actually need. So has anyone here ever heard of YAML hell? Yeah. How about, has anyone ever spent a night, say, debugging a 10,000 line MS Build script? So, okay, great. So, yeah. If we suppose that not every development team has the resources and well, money available to actually have its own dedicated DevOps team to support their various builds, then we can start to realize that the tooling should probably be made to fit the developer's needs, while also maintaining all of the features of the previous all of the previous features that I've described. And what are some of the ways that this could be achieved? So let's put together some characteristics of a quote-unquote perfect build automation tool. So it needs to be easy to set up, right? Adding some build automation, some scripting to an existing solution shouldn't be hard. It would need to be easy to run. So I shouldn't have to depend on external software to be installed in order to run it. Think click to run. So the next thing, it needs to be easy to change. Our software constantly evolves. This means that our builds should evolve, or they do evolve with it as well. So it doesn't make sense that a developer should learn an entire framework or read an entire book just to add a step to a build that is already there. And let's face it, we make mistakes. such software should be easy to debug. That's just a fact. And of course, it needs to be cross-platform. This means that such software needs to run exactly where your code runs. That's the basic idea. And the last thing, which I've already talked about a bit, and this is, it needs to have some sort of a way to integrate into existing continuous integration systems, just so it can utilize its resources to the fullest potential and also offer that extra edge that the tool actually works locally and on a CI server, and it doesn't really matter what CI server it's running on. So I had an idea that perhaps we can attempt to build a tool that would try to deliver on some of these characteristics. So now I am going to switch over to my IDE, and we're gonna start a simple demo. But before that, I would like to actually point out that there are currently build automation tools, such as I'm describing now, that are out there in production. So, for example, Cake Build or Nuget Build are just a couple of tools that have a really strong community. They're very well liked in community and also used in production by several large companies worldwide. So I would really encourage you to read up on them if you have the time, and perhaps we can have a discussion about them at some later time. So, okay, let's get started. I'm just gonna switch over to my IDE. I'm gonna turn a bit away from you, just so I can see what I'm typing. And this is what we're starting with. So what I have here is a simple Blazor application. It's not actually related to what we're trying to do. It's just something to showcase that we can build, okay? So when we are going to spin the application up at the very end, but it's basically a front end with a simple back end. So let's try to add some build automation here, right? So the first thing that we need to do is we actually need to install a tool. And like we mentioned previously, this should be very easy to install. So has anyone ever heard about .NET templates here? Okay, and what is where the tool is located is actually in the .NET templating repository. And this means that when you have .NET installed, you have the access to this build script. Now, what the action that I just executed did was to actually install a couple of templates and a template runner locally, so we can then use it anywhere we use .NET. So let's try to add build automation to our existing solution. So let's just write .NET. By the way, this is the point where I usually forget how to type, so just bear with me. Let's add a new build, and let's name it something original, like a build. Okay, now we can see that Visual Studio just nagged that something has been modified. So let's see what actually happened here. Okay, great. So there's been a solution, a project added. And if we look at Git changes, we can also see that there was a PowerShell script of sorts added. So let's spend a couple of minutes actually dissecting what is in here. Has anyone ever worked with minimal APIs in .NET 6 before? Okay, so the idea here is to not spend a lot of time to actually get acquainted to how the tool actually works. So if we take it from the top, we can see that we have a host builder, which is exactly the same as when you do it in minimal APIs. This one actually preps your entire environment and gets ready to configure it according to what we actually need here. So we are going to, at a later point, use Azure Pipelines. We'll get to that later. And we are going to use .NET CLI because we need to build some projects. And later, we are going to define a set of tasks and their relations. So if you remember on my previous slide, I showed that relation with the different build steps of a task. So this is basically a simplified version. What we have here is we have a publish step, which depends on a build. which then in turn depends on the restore, which then in turn runs something. Now, these tasks are just basic functions. It's not anything specific, so it's a function that returns a task, just so we can run it asynchronously, and it takes any number of parameters which are actually resolved from our dependency injection mechanism. So they're not predefined of what exactly needs to be in here. So without further ado, let's try to run a build task and see what happens. And what's going on behind the hood is the tool is checking if the .NET exists. If it doesn't, it will install it. Then it checks if all of these tasks that I'm evoking actually exists. It creates a sort of a dependency flow, and then starts executing tasks from the start. Now, if you see, there was an error here. So one of the things that we want to have in a build automation tool is a way to quickly debug what's going on, right? You don't want to have specialized tooling or other utilities that you need to install somewhere to actually see what the problem is. So let's just debug the build and see what happens. And just so I am very explicit, this is what was shown on my other screen. So basically I'm going to select that very same instance of Visual Studio. It's gonna stop in the run task, and if I press continue, I'm gonna see that there is oh look, there was an error thrown. So basically someone forgot to remove that. So let's remove it and let's try to continue. Okay, and if we run the build now without actually debugging, we can see that it will succeed. Awesome. Okay, let's try to deploy this to a CI system. I've chosen Azure Pipelines for that specific case. So what do we need to actually create a pipeline in Azure? We need a YAML file, right? So as you might have noticed, at the very top, I instructed my build automation system to use a sort of an integration that actually integrates with Azure Pipelines. And at that point, when the application is already running, I told the system to actually map the build task and to make sure that Azure Pipelines actually triggers when a branch main is updated. So let's try to actually create that script. So what I'm going to do is I'm going to say I'm going to create the Azure Pipelines, as you can see, what was created here was a script that triggers on a main branch. It uses Windows latest, I don't know, I think it's the default image, and it runs several different tasks in a flow. So basically, it first runs restore, then it runs build, and then, well, it doesn't run publish. So let's just fix that real quickly to see that it is possible. So those are there are no magic strings involved here. Basically, you're working with first-class citizens of the language. So basically, we are just referencing that function that is defined down here. So if we save this, rerun our integration again, and it shouldn't take long to actually run this integration. We can now see that we do have a publish task available. So let's try to actually commit all of this. This repository is actually hosted on Azure DevOps. So what I'm expecting when I commit and push these changes is for the pipeline to be created. And because we are pushing to the main branch, it actually needs to start. So let's just wait for a moment and then switch over to our Azure environment. As we can see, I just need to refresh it, and oh look, it's already running. So what this does is actually it calls this tool that we have under the hood. It is specified so that the resources and the tasks are actually separated according to the best possible, let's say, utilization that it can provide. And this is going to run for a couple of minutes, but what I expect at the end is for the entire job to succeed. So that was basically my plan as to what we want to do. But if you would like, we can create a simple deployment step and actually deploy this application to, say, somewhere in Azure and see if it's running. And I'm hoping that this will not take more than a couple of minutes, because that's what I'm trying to defend here, that the tool should be simple. So what we're going to do here is paste a task that already has all of these steps predefined. And what this does is it uses Azure CLI to actually run 4 different tasks in a row. And first, what we need to do is we actually need to instruct the tool to map and to see if the Azure CLI is actually available. So just say use AZ CLI. Great. And the next thing that we need to do is we actually need to define that this task actually exists. So if we map a task called deploy here, we can now just invoke the deployment task whenever we need it. There is another thing to consider here. So basically, deployment is usually a separate step, so it's the CD of CI/CD part. But just to make things quick here, I'm going to be depending on the publish task, just so we have all of the artifacts in place. But what we could do, or what should be done in reality, is to actually save the artifacts from this continuous integration pipeline, and then run a continuous deployment pipeline at a later stage, perhaps even multiple times. So with that out of the way, let's try to actually run this and see if that works. This is the part I haven't rehearsed, so it may fail, and then we're gonna just move on. Okay, so what the script is actually doing is it's creating resources on Azure. It's creating a separate resource group. It's creating an app service. It is creating a web application. It is zipping up, or it uses the zipped deployment package, and it will actually deploy the package while we wait here. And this usually takes less than a minute, so I'm going to hope that it takes less than a minute here as well. And meanwhile, I'm just gonna find a URL that we can later navigate to. Oops. And let's see. There should be a default something here. Here you go. Okay, and let's see what happened here. Okay, so it said that the app was created via push deployment. So now if we go to our browser, we actually just use that URL that was received previously. Our simple Blazor application should work. And this means that we have now created from scratch an entire build workflow, including CI and CD. Now, this build workflow is really simple. It's usually a lot more complicated. But what I was trying to convey here, it was basically an experiment if that could be done. So hopefully I've managed to to trigger some interesting questions. So with that being said, that's it for my main presentation. And what I have here is a slideshow. Is a set of QR codes where you can find either this tool or the application, demo application that I've just been demoing. And yeah, that's it. Questions?
Yeah. Very interesting. Did I understand it correctly? If this makes it possible to use other integrations than Azure DevOps. So
that's the idea. The idea is to actually be very open-minded as to what CI servers or continuous integration servers could be utilized. And again, this was an experiment. So if I fall back to an option, which I usually do when coming to production scenarios, Nuget build, for example, has support for all of the servers that were previously listed. So Azure DevOps, TeamCity, GitLab, and basically what it turns out at the back, what happens is that someone needs to configure the way that pipelines are defined in each specific tool and then invoke our tool. And this could be done in a way that is most useful. So there are multiple types of dependencies between different tasks. For example, you could run several tasks in parallel, which is very great because, for example, GitLab can actually spin up its own agent for each of these steps. So that's something to consider. And of course, then you don't have to defend your unusual approach to actually using build automation, because if someone tells you that you don't have a GitLab pipeline and we use GitLab, you can just tell them, no, I do have it. So.
Are you the creator behind this? Or?
Yeah, that was really, it was, so it's a funny story. I was actually in Sweden and I got sick from COVID, and I spent 3 days in isolation, and that's what happened. So, yeah.
Any users?
No. This is completely, like, this is the first debut of the tool. I'm willing to share the code because this code is really, like, it's really, I need to really emphasize that it's an experiment. So feel free to browse through the code, but don't use it, please.
Do you have any options on how to run manual stages in it?
Yeah, so basically what happens behind the scenes, for example, we can actually see in our wait, let me just open code here, and of course it's opened on a completely different screen. Why not? If we have a look at this Azure Pipelines pipeline, we can see that the tool that is actually invoked is invoked in the skip dependencies sort of a way. So basically you say, run only this task. I don't care about the dependencies that are before or after. And this is, at least as far as I know, this is the only way to actually break apart a build and then run it in sections from a different tool. But the idea behind that tool that I was actually demoing is it can be extensible. So everything should be ready for, so basically if you need a way to run, say, 3 tasks in a row, it should be as easy as writing an extension method. So, any other questions?
But there is a translation you do to the format that Azure Pipeline, for example, expects.
Yeah, there is a translation. It is basically, well, there's a schema for Azure Pipelines, and that schema is basically mapped to different concepts in this tool. So I'm not
available.
Well, to a degree, it doesn't need to. So basically, when you use a tool, and again, I want to reiterate that we are talking about a conceptual system, not a real one. But basically, when you say use .NET CLI, the tool should make sure that .NET CLI is installed and ready to use. And the same goes for Azure, AZ CLI. So basically, all of these tools could be installed via a script. And exactly. So basically what you need is a PowerShell or a Bash script at the other side, and everything else is taken care of.
is if I duplicate row 7 here, so it does Usenet CLI.NET.
No, it's a simple. Like that, you mean?
Yeah.
No, it should be a simple. I mean, the dependency injection mechanism should take care of actually deduplicating dependencies, because what happens here is there's actually just another type of dependency added to Microsoft's DI, and it works. Questions or?
Well,
Great. Awesome.